Okay, Rameshwar, you asked one question.
Yes, sir.
What is your question?
When we cut into the bar magnet in 2 pieces.
Correct. So, suppose this bar magnet, we are dividing it into 2 pieces. Correct?
Yes, sir.
So, we have divided it into 2 pieces. Okay, this was south, north, and then again north and south is created. Right. Then, so what I told that in between that magnetic lines of force is not denser, that much denser, and near to the pole only that lines of force are much more denser.
Yes, sir.
Lines of force are much more denser means what? It is having a very high magnetism near to the pole.
Yes, sir.
Correct or not?
Yes, sir.
Okay. So if the lines of force are more denser towards the pole, near to the pole, then it will be having high intensity of magnetism. High intensity of magnetism will be there near to the poles. You have asked that if we are cutting it into 2 pieces, then already it was not having that much intensity
Yes,
of magnetic lines of force in the middle region.
Yes, sir.
So that will affect new piece or not.
Yes.
Okay. So when what you are doing, when you are having a full bar magnet, at that time in the middle there is no pole.
Yes, sir.
In the middle region,
No pole.
is there.
Yes, sir.
Okay. Now when you have cut into 2 pieces, now poles have been generated.
Yes, sir.
Now due to the generation of this pole, again here intensity of lines of force will get increased
Yes, sir.
due to the generation of poles. Earlier here poles were not there.
Okay, sir.
Okay. So wherever poles will come, okay, wherever you are generating any pole by cutting it into 2 pieces or 3 pieces, then intensity of lines of force at that particular pole also will be increasing. Correct?
Yes, sir.
Okay. So now we will discuss properties of lines of force. So properties of lines of force. Right. So properties of lines of force, what we can write? We can write that no 2 lines of force intersect each other. That is one property. So you can say 2 lines of forces. Here we are talking about magnetic lines of force, not electric lines of force. Okay. So better we will write 2 magnetic lines of forces. 2 magnetic lines of forces never intersect each other. Right?
Yes, sir.
Okay. Then second, the intensity of magnetism near to the poles will be higher than in the middle region, right?
Yes, sir.
In the middle region. Okay? The same we can verify with the activity also what we have conducted with a piece of paper, and by keeping that iron bearings and moving that bar magnet at the bottom of the paper. So the same lines of force we will be able to observe it. Okay? Right. Very good. So about magnetism, any doubt now?
No, sir. No, sir.
So about magnet. So what we have discussed? What is the magnet?
Magnet and magnet.
What are the types of magnet? Natural magnet and artificial magnet.
Yes, sir.
What is magnetism?
Yes, sir.
Okay. And what?
Properties of the lines.
What is a magnetic field? What magnetic lines of force is? And properties of lines of force. Okay? Right. Now, we will be discussing about the main points of this chapter, that is effect of electric current. Till now what we have discussed about magnet and its properties.
Yes, sir.
We discussed about magnet and its
Properties.
Okay, now what we need to find out? We need to find the relation between this electric current
And the
and magnetism.
Yes, sir.
Relation between magnetism and electric current. Okay, so relation between magnet and electric current. See what happened? Oersted, one scientist, physicist, one physicist. His name was Oersted. So what he found, it was an accidental discovery. It was an accidental discovery. Okay. So what he found, that suppose a battery is there and an electric current is flowing over this wire. An electric current is flowing in this wire. Okay, so that electric current is flowing in this direction. Coming. So what he found, Oersted. So what we are saying, accidental discovery, correct?
Yes, sir.
So accidental. What is the meaning of accidental?
Anything. Without knowing that.
Yes. Sudden observation. Sudden observation. Not with any plan at all.
Yes, sir.
Okay. So sudden observation. What he observed, that when a current is flowing on a wire, okay, and one compass needle. Suppose if it is placed near to that compass needle, okay, so that compass needle is getting deflected.
It will not be stable, sir. It will be rotating.
It will have some deflection.
Yes, sir.
Okay, so the moment one compass needle generally, which is that compass you have seen,
Yes, sir.
Yes,
so
sir.
that compass needle is aligning itself in north and south region.
Yes, sir.
Always it will be aligning itself in north and south. So you can say on our earth also we will be able to find that which direction is north, which direction is
Yes,
south. Okay? If you are able to find north direction, every direction you can find out.
Yes.
Why? Because we are going that north. So generally north is here at the top
So,
and south. Then this side will be
east,
east, this side will be
west.
west. Okay?
Yes, sir.
So what was the accidental discovery of Oersted? That when a compass needle is brought near to the wire which is carrying current,
Yes, sir.
that compass needle had shown some deflection. Compass needle has shown
Reflection.
deflection. Deflection.
Deflection.
Okay, means that compass needle has moved.
West.
That compass needle has moved either east, west, whatever it is. Okay, that compass needle has shown some deflection. So that deflection is due to the presence of current. When this compass is taken away from this current carrying wire,
Normal.
again it is normal. There is no deflection. When it is brought near to the current carrying wire, it has shown some deflection.
Yes, sir.
Okay, so what Oersted observed, that this current carrying wire is also producing magnetism around it.
Yes.
Yes, sir.
It creates a magnetic field around it, and when this compass needle has entered in that magnetic field, it has shown deflection because it has tried to align its needle along with the north and south direction of this magnetic field.
Yes, sir.
Right or not? Okay, so the same thing it is there. So what Oersted has discovered, that we will write. He observed, Oersted observed that when a compass is brought near to the current carrying wire the compass needle shows some deflection. Showed some deflection, indicating the presence of magnetic field. Understood this point?
Yes, sir.
So Oersted, what he observed, that when a compass is brought near to the current carrying wire, the compass needle has shown some deflection. So when it will be showing some deflection, when it will be coming in the region of magnetic field, when it will come in the region of magnetic field.
Yes, sir.
Okay, so then only it will be showing some deflection.
Yes, sir.
So that only Oersted observed suddenly. Correct? Okay. Good. Can I interrupt here?
Yes, sir.
Okay. So this is the relation what Oersted has found, that there is a relation between this current and magnetic field. Okay, some relation is there between current. When this current is stopped, okay, when this current is stopped, again this needle has not shown any deflection. So he has tested several times. He stopped immediately current flowing in the wire, and when he brought this compass needle in front of this wire, so no deflection has taken place. Again he started flowing of current. Again the deflection has taken place in the compass needle. Then he found that it is due to the presence of some electric field, which is magnetic field, which is created by this current. Okay. So a current carrying wire, so you can say a current carrying wire creates a magnetic field around it. Okay?
Yes, sir.
Right. So the magnetic field, now direction of that magnetic field. Okay. Direction of that magnetic field. Can I rub this side?
Yes, sir.
So you can create that magnetic lines of force in two ways. Magnetic lines of force. One is by using that iron film and putting it on a piece of paper. Okay, so you can create that lines of force surrounding to the magnet. Another way is you just bring not that compass needle here. You just bring that compass needle here in front of the north pole. Okay, any pole you bring it in front of north pole or south pole when you are bringing. So this compass needle, due to its presence, it will deflect and it will align itself to north and south direction. It will be aligning itself to north and south direction. So it has aligned. Okay, just mark here. Just put one dot. Correct? Then again you come here and again you place this compass needle. Again it will align itself in north and south direction. Right? Then put one dot. Again it will be aligning itself in north and south direction. So when you are doing with this compass needle, by placing it at several places, you will be able to find that how that it is moving
Around the
in this direction. Okay, so now north and south pole. So the magnetic lines of force is moving from north to south pole, outside the magnet. Inside the magnet,
The current
from south to north.
north is
Okay, inside the magnet, from south to north. Right?
yes, sir.
Okay. Now we will be discussing about direction of electric field. Okay, one more thing what you can do here. This is for magnet. This is for magnetic lines of force, and when magnet is there.
Yes, sir.
Now when we are talking about current carrying wire, when we are talking about current carrying wire, so you can say that right now already the current is moving in this direction I, right? So this is through this hole, this wire is moving, and this is the cardboard, you can say one cardboard you have taken, you have made one center hole, and this current carrying wire is moving through that hole. Now what you are doing, you just sprinkle iron filling. Just sprinkle means just you drop some iron fillings around in this cardboard. Okay, and now you make the current to flow, and just you have like this tapping. You will find that this iron filling is arranging itself around this wire
without any magnet.
without any magnet. Now this current carrying wire itself is creating a magnetic field.
Okay.
So in order to identify magnetic lines of force around this current carrying wire which has created a magnetic field, you are doing this activity. In this activity what you are doing? You are taking a cardboard, you are making a center hole, making the current carrying wire to pass through that center hole, and then some iron fillings are dropped surrounding to that wire. When you have made the current to flow on that wire, these iron droppings, iron fillings will align itself in circular direction, showing that presence of magnetic field. Showing presence of magnetic field. Correct? Okay. Here you are not using this bar magnet.
Yes, sir.
Yes, sir.
Okay. Here you are using current carrying wire. So this activity is clearly showing that one magnetic field is created by this current carrying wire. Right?
Yes, sir.
Okay. Now we need to find the direction of magnetic field. We need to find the direction of magnetic field. As we have already discussed that magnetic field is a vector quantity having magnitude and direction both. So we need to find direction of magnetic field. Now, okay. So this experiment you have understood?
Yes, sir.
Okay. Right. Let us discuss about direction of magnetic field. So that is given by Fleming's right hand rule. Fleming's right hand thumb rule. Okay, good. So Fleming's
Right hand.
right hand thumb rule. So what it is there, that Fleming's right hand thumb rule. In that Fleming's right hand thumb rule, when suppose this iron rod, okay, this is the iron rod which is carrying a current in this direction from top to bottom.
Yes, sir.
Okay, so now what you are doing, you are putting your thumb, right hand thumb in the direction of current. In the direction of current. So you are holding this
Yes, sir.
iron rod like this.
Okay, sir.
So this thumb is in the direction of current.
Yes, sir.
Okay. So now the curve of your finger, this curve of your finger will be showing the direction of magnetic field.
Okay, sir.
Okay. This curve of your finger, this finger will be showing the direction of
Magnetic
field. So in this direction, suppose it is there, so it will be in this direction. Right?
Yes, sir.
Okay. When you are reversing the current,
Yes, sir.
when suppose you are going for reversing the direction of current. So what you are doing now? Here you are using in the direction of current.
Yes, sir.
So now this curve of your finger will show the direction of magnetic
Magnetic
field.
field.
So it will be in this direction. The direction will get reversed.
Yes, sir.
Understood?
Yes.
Okay. So how Fleming's right hand rule we can write? We can write that if the right hand thumb is placed in the direction of current, the curl of the fingers of the other fingers gives the direction of magnetic field. Magnetic field around the current carrying conductor. Understood, Rameshwar?
Yes, sir.
How to find the direction of magnetic field?
Yes, sir.
Okay, so what you have to do? You have to hold the conductor and place your right hand thumb in the direction of current.
Okay, sir.
Right? Okay, when you are placing your right hand in the direction of current, right hand thumb in the direction of current, the curl,
Yes,
the curl of the finger will be giving you the direction of magnetic field. Okay, so this is Fleming's right hand thumb. Okay, so we will stop here only today.